I'm Josh, VK2FJDX. Today's video presentation is about the G40 transceiver kit by Genesis Radio. Part 1 of the video series is going to be about the adjustment, the troubleshooting, and the assembly of the G40 receiver. I will also be showing you a simple yet effective way how to adjust the image rejection. The G40 is a hardware that turns your PC into a high-performance amateur radio transceiver with the help of SDR softwares. It operates as a multi-mode 40-meter band two-way radio with a power output of 5 watts. A typical amateur software-defined radio uses a direct conversion receiver and a low-power transmitter. The mixer technologies are now based on the quadrature sampling detector and the quadrature sampling exciter. In the long term, software-defined radio is expected by its proponents to become the dominant technology in radio communications. My setup for the purpose of this demonstration consists of the fast computer with an inbuilt sound card and of course the Genesis G40. Let's start with phase 1 of the G40 assembly. This phase is very straightforward and consists of the installation of the voltage regulator and a few associated parts. The purpose of the voltage regulator is to provide a 5-volt output for the receiver's integral circuits. After the installation of the components in phase 1, check the output voltage and it should read exactly 5 volts. Also, the green LED diode will be on. Phase 2 is the installation of the local oscillator, which resonates at a frequency of 28.188 MHz. Practically, you would install one 74HC04 hex inverter and a 28.188 crystal, along with a few resistors and capacitors. The beauty of this phase is that upon completion, you can easily check the performance of the oscillator. Tune your HF radio receiver on 28.188 MHz and you'll hear the sound. In the next phase, you will install the integral circuit divider 74AC74. The divider divides the local oscillator signal 28 MHz into 4 quadrature signals, each resonating at 7.047 MHz. Again, this phase is a very straightforward one. Upon completion, tune your HF receiver to 7.047 MHz, where you can hear the oscillator signal. Please note, do not actually connect the receiver input directly to the G40 board. Rather, use a piece of wire as an antenna. Here's my troubleshooting tip for the divider phase. If you can hear the local oscillator signal at 28 MHz, yet can't hear it at 7 MHz, double check that you've installed the 100 nF capacitor that connects the oscillator and the divider. Let's go to phase 4. The G40's mixer is a double-balanced sample and hold circuit using 2 quad bilateral analog switches, 4066. The incoming RF is split into 2 strings, each going to 2 pairs of switches. The resultant outputs of the mixer circuits goes to the operational amplifiers, NE5532s, to produce the I and Q signals for the sound card processing. This phase is fairly complex as you're installing many components. Pay close attention to the values of the capacitors and resistors you're installing. Also, pay close attention to the orientation of the integral circuits. After you've assembled all the components in phase 4, your G40 is ready for preliminary adjustment. Do not connect the input voltage yet. With a fine screwdriver, adjust the trimmer Y501 until the resistance across the 330 ohm resistor is 150 ohms. Note, at this stage, do not touch or adjust the other two trimmers. They must remain to their set factory standards, 2.5 kiloohms. Now, reconnect the input voltage. Check the current consumption, it should be around 120 milliamps. Also, check the voltage on all four NE532s. The voltage on the individual pins will depend on the input voltage, and may be any value between plus 5 volts and plus 6.5 volts on pins 1, 2, 3, 5, 6, and 7. However, it is very important that the voltage on all four pins of the amplifier is identical. The next step is to set up your radio as a signal generator. I've prepared my setup in the following way. The transmitter is connected to a dummy load, the power is reduced to 5 watts, and the electronic keyer is set to dots. I'm now transmitting at 7044. I'm using my G40 receiver to listen to the transmitted signal. Again, a short piece of wire serves as an antenna. I'm going to connect the stereo headphones to the G40 output. I can hear a clear string of dots on both channels. That means both the I and Q channels are working fine. Now I finally connected the G40 output to the sound card input. I'm using WinRAD SDR software, and my signal generator is the VK2 transceiver. It's set to 7044 MHz. Now observe the WinRAD signal spectrum. Note a rather big spike at 70477. This is the frequency of the local oscillator, and this product is really unwanted. At this point, there's nothing we can do about it. The signal on 7044 is our main receiving signal. Now observe its mirror image, an unwanted signal which is at this stage rejected by only 20 decibels. This is the signal we need to reduce even further. The adjustment process is to tune the Y501 trimmer until we find the exact spot where the image is rejected to its minimum. This point is 1 to 2 turns away, and I'm fine-tuning the trimmer in each direction. Here you go. The image is now rejected by approximately 50 decibels below the main signal level. Once again, this is our transmitted signal at 7044. The local oscillator at 7047, and the rejected image at 7050. Our G40 is now adjusted and ready for the next phase. Thank you for watching my video. Good DXing 73.